Okay, so question 8. This is a polyester and it wants an equation for alkaline hydrolysis of it. So you can see it's a polyester because there's the ester linkage in the middle there. And you can see it's one of those that's formed from two monomers because you've got the pair of carbonyl groups with a carbon chain in between, pair of oxygens with the carbons in between. So that's a polyester that's, when it hydrolyzes, is going to break down to two different monomers. So the thing to do is to say, right, that's the repeat unit. So if we're going to write this as an equation, the whole thing is the repeat unit. So that is repeated n times. And it's going to require 2n waters to break it down, because we need one for each of those linkers in the middle of the repeat unit, and then one for each of the linkers between the repeat units, so 2n waters. And again, it's just the reverse of the fact that 2n waters were produced in the condensation reaction. So if you remember, it's the reverse of condensation, then it's pretty easy. So we get 2n waters. And then the product, well, we're going to get a dicarboxylic acid from this bit. So that'll be that half of the repeat unit dealt with, and then this bit is just a diol because each of those oxygens came from an alcohol group, and so we're just going to get this. And we're going to have n of those and n of those. But now again, we've got to be careful, because remember, it asked not just for hydrolysis, but specifically for alkaline hydrolysis. So we've got to change this and think what would be different as a result of it being an alkaline. So alcohol groups, key thing to remember about those is that they are not acidic. So they don't care if you add alkali, they will just ignore it. But the carboxylic acid groups, of course, are acidic. And so in the presence of alkali, those will change into the salt, and so you'll get O minus Na plus if it says sodium hydroxide. It didn't actually specify sodium hydroxide, so let's leave out the Na plus and just put those as O minus. And that again means that it unbalances the equation, because we've taken two H pluses away from there. We've got to take two H pluses away from here, and that then becomes 2N OH minus to balance it. So that's your equation. Okay, so again, same strategy as before. Write it out as a reaction with water, and then tweak it and say, well, what will be different as a result of the specific kind of pH conditions you're using. Now this one, which is part B, it says acid catalyzed hydrolysis of a polymer formed from that. So your first thought's going to be, well, that's a trick question, because hydrolysis is just the reverse of the condensation polymerization, and therefore if you make it into a polymer and then hydrolyze it again, you'll just get the same thing back. But again, you've got to think about, what about the effect of that acid that's used in the hydrolysis reaction? Now in this case, there's only one kind of polymer, so it's not that you, one kind of monomer, so it's not that you're going to get two different monomers. But what you have to notice is that there is another ester group in there. Okay, so if we just draw a ring around it here. So that wasn't involved in the polymerization, that was just there as part of the molecule. But of course, under conditions of acid hydrolysis, that will hydrolyze as well as breaking the polymer back down into the monomer chains. So you're going to get something that's almost the same, but this will have broken down. And of course, when you break down an ester, you get an alcohol and a carboxylic acid. So we'll get OH there, and COOH there, and the rest of it is just the same as it was before. And then again we check, is it acid or alkaline hydrolysis? This time it's acid hydrolysis, and none of those groups is basic, so none of them is affected by the acid, and so that will be the product. But that was the little trick in there, spotting that there was another ester unit within the monomer which wasn't formed by the polymerization, but nevertheless is an ester group and therefore will be sensitive to acid hydrolysis. Okay, so question 9 is asking you to contemplate polymerizing this compound which they've drawn for you, 3-hydroxybenzoic acid, with this one which you had to figure out, which was 3-hydroxybutanoic acid. And you can see that what you would expect if you actually tried to polymerize this mixture is something quite complicated could happen, because this compound could polymerize all on its own, because obviously the carboxylic acid of one could condense in principle with the phenol of another and create a chain that way. Similarly, this could form a polyester all with itself, carboxylic acid of one molecule of this condensing with the alcohol of that, or they could condense with each other, which is what they're asking you to think about. It would take some clever chemistry to control that and make sure you got one particular product, and you don't have to worry at A level at all about how you might do that. So all it's asking you to do is to say, if you could find a way to do it, what would you get if you alternated a repeat unit from that with a repeat unit from that and then back to this one again. So that actually makes it very straightforward, because you know that that phenol group is going to be form a linking ester group. So that just becomes oxygen, as in the other polyesters we've seen, and likewise the carboxylic acid group is just left as C double bond O. We're going to condense out that water there, so this carbonyl will now link to this oxygen down here, and then we can draw that in again, and once again the carboxylic acid group is just left as a carbonyl group, and there's your linker on the end. So it's a situation which would in principle be in practice be very complicated, but in principle just gives you that as the repeat unit.